Hello students, myself Tejaswini, lecturer in ENC from SJ Government Polytechnic, Bangalore. Today I am going to deliver a lecture on classification of PLCs. Before that, we will see what we have learned in the first session. We will have a small recap of the first session. We have learned what is the definition of PLC. What is PLC? It is nothing but a device which we are using to control the industrial automation. Then we have also seen why we need PLC. What are the leading brands of PLCs? What are the applications of PLC? And then the major components of the PLC. What are the major components of the PLC? The first one is the CPU, that is Central Processing Unit, and we'll be having the memory, then power supply unit, then programmer or monitor, then racks and chassis. Whichever the basic PLC you consider, these are the major components of the PLC. Okay. And in today's session, we will be learning what are the classification of PLCs. First of all, why we need to classify the PLCs? Can't we use the same PLC for all the applications? Yes or no? No. Why? Because the applications, it will be a small application, we'll be having the major applications. That means these PLCs we will be using in the industries as well as in making of the toys also we will be using the PLCs. So for both the applications, can we use the same PLC? No. Why? Because for industries and all, we need the higher PLCs, that is the IO ports, memory required or more. But for the toys and all, the requirement of IO ports, memory, etc. are very less. Okay. So that is why the PLCs are classified. Now we will see in detail how the PLCs are classified here. First, we will see the types of PLCs. We are having two types of PLCs here. The first one is modular PLC and the second one is compact PLC. What is modular PLC? Modular PLC. This modular PLC, it will permit multiple expansion through modules. Hence, it is referred to as modular PLC. If you see the block diagram of a modular PLC, you see we are having power supply, CPU, interface module and other modules it will be having the empty. These are all mounted on the racks, inside the rack. Okay. And this is here, for example, if all the components that are in the modular PLC, they are all independent to each other. We will connect all the modules and we will form into a PLC system. Okay. And here, for example, if for any other application, we want to increase the IO modules. So here, using this modular PLC, we can increase the IO modules. Or if we want to increase the memory, we can also increase the memory here, memory module, by putting the memory module. That is why this provides the multiple expansion. That means we can keep adding the components how much ever we want. So it is easier to use because each component is independent of each other. Understood? So this is the modular PLC. The other diagram you can see how the modular PLC looks like. These are all the independent components we are connecting manually to form a PLC system. Okay. And these type of modular PLCs, these are more desirable in large industries. In the industries, they'll be using this type of modular PLC more. What are the advantages of using these type of PLC? First one, scalability. by using this modular. Why scalability? We'll be having the greater scalability. That means because we can add the components, whether it will be IO modules or memory, etc. That is why it will provide the greater scalability. And next advantage is it is easier to find the faults in these type of modular PLC. Why? Because all components in these type of PLCs, they are independent to each other. Okay. If any fault is occurred, we can easily find the fault. And here it is having the less downtime. Why it is having the less downtime? Since these are all independent to each other, if any fault is occurred, we can easily remove that module and we can repair it and we can fix that in the PLC system. So it needs very less downtime to repair it. Okay. And even memory also we can expand how much memory we want. So these are some of the advantages of using modular PLC. Understood? So modular PLC, this will permit multiple expansion through modules. That is why the name modular PLC. Okay. Now next we will see the second type of PLC, that is compact PLC. In the name itself, it is the compact. It is very small in size. It is also called as fixed PLC or integrated PLC. Okay, all are same. So it is also compact PLC is also called as fixed PLC and integrated PLC. Integrated, that means all components are integrated in a single case. Okay. And in the block diagram of compact PLC, you can see here inputs, power supply, CPU, output, all are in a single case. And this side you can see the diagram of compact PLC, how it looks like. Okay. See, in the compact PLC, these all will be integrated in the single case. Okay. All the modules. And here in this compact PLC, it will be having the fixed number of IO modules and external IO cards. It will be fixed. We can't add any extra modules to this compact PLC. And whatever the inputs and outputs are there, here it is decided by the manufacturer. We can't add any extra inputs and outputs to this PLC. Okay. And the PLC are divided into three types based on output. Namely, we'll be having the relay output type, transistor output type and triac output PLC. The relay output type, it is best suited for both AC and DC. If we are using for both AC and DC output devices, then we can go for relay output type. And transistor output PLC, we will be using these type of PLC where we are having the switching operations. Generally, this is used inside the processors, that is transistor output type PLC. And one more we are having is triac output PLC. In this triac output PLC, the current will flow in both the direction. This type of PLC they will be used where the AC output devices are used. Okay. So now you got the difference between what is modular PLC and what is compact PLC, right? So in the modular PLC, it provides the expansion of the modules. We can add IO modules, memory modules, power supply units, etc. It will provide expansion. But in case of compact, it is a fixed one. That is, whatever the manufacturer has decided, those things will be there. We can't add any extra things in the compact PLCs. Okay, now you got the difference. Now we will move on to the next topic, that is classification of PLC based on IO modules and application ranges. The PLCs again we are classifying based on the input-output modules and also on the application ranges. First we will see how we are classifying by I/O modules. The first one is discrete I/O system. It is nothing but the digital system. And the second one is analog I/O system. Based on I/O modules, we are dividing it into digital I/O systems and analog I/O system. So digital I/O system. So this system, it will provide a physical connection between your CPU and the field devices. But here the transmit and receive signals, these are of digital signals, that is zeros and ones. Okay. And in case of analog I/O system, analog input modules, these are used in applications where the field equipment signals, that is the signals are of continuous in nature. Example, the pressure, temperature, these signals are called continuous signals. Okay, there will be going for analog I/O systems. So analog output module are used in applications which need to continuous voltage or current levels for control. An example of this type of device is an electrical motor drives. It is a continuous signal. Okay. And next, again the PLCs are classified based on application ranges. Here it is divided, the PLCs can be divided into 5 groups. Here we can see the micro PLCs, small PLCs, medium PLCs, large PLCs and very large PLCs. See, even before the micro PLCs, we are having the nano and pico PLCs. In those kind of PLCs, we will be having the I/O devices less than 15. Okay, then those are called as nano or pico PLCs. Those kind of PLCs we are using in the PLC trainer systems. PLC trainer systems means in the lab what we are using the PLC trainer kits. It will be hardly having the 15 I/O devices. Okay, there those kind of PLCs are used. Next one is the micro PLCs. Micro PLCs, this will be having approximately 32 I/O devices. And small PLCs from 32 to 128 I/O devices. These micro PLCs and small PLCs we will be using in the small automations. Small automations means like in the amusement parks. In the amusement parks we'll be having so many amusement rides. Okay, to control those things, they'll be going for micro PLCs and small PLCs. And the next one is the medium PLCs. In the medium PLCs, we will be having 34 to 1024 I/O devices. This will be using in the industries. I mean, small industries will be using these type of medium PLCs. And if you go for large PLCs and very large PLCs will be having 51202 4096 I/O devices and very large PLCs which controls 2048 to 8192 I/O devices. These type of PLCs will be using very large plants like power industries, then steel industries, okay, automobile industries. There will be going for this very large PLCs, especially in those industries for the SCADA and the distributed control systems. For those things, they'll be going for very large PLCs and large PLCs. What is SCADA and what is distributed control systems? These things we will be dealing in the upcoming chapters. Okay. And here if you see the diagram here, A, B and C overlapping areas. They are the these are the A, B, C. A, B and C are the overlapping areas in this figure. See in the figure if you see till 32 it is the micro PLCs, 32 to 128 it is a small PLC, 128 to 1024 it is a medium PLC, 1024 to 4096 it is a large PLC and from 4096 to 8192 it is the very large PLC. And A, B, C, these areas, it refers to the extension of I/O modules. I mean, till 64 it is not the PLC. So in the small PLCs we can extend till 128 IO devices. Same thing for the medium PLC and large PLC also. Okay. So till now we have seen how the PLCs are classified even based on the IO systems and application ranges. In the IO systems means we are dividing based on analog and input. Which type of input or output we are required, whether it is analog signal or digital signal, and also we have seen based on the application ranges. Now we will see selection criteria of PLC. If we want to do particular task, okay, how we are going to select the PLC. That is the most important thing because we can't use the same PLC for all the tasks. The first one is necessary input output capacity. So for the task, how many inputs are needed for that particular application? How many outputs are needed? So if we know how many inputs and outputs are needed, then we can decide whether we need the small PLC or we need the micro PLC like that. Okay. See, for example, for our application, if it hardly requires some 30 IO units, okay. If we purchase a medium PLC, okay, or small PLC, then it will be the waste of money. So we have to decide. And types of IO required. Types of IO means in the last slide we have seen IO, whether it is the analog input or output or digital input or output, which one we need. Then size of memory. How much memory is required for our task? See, because if more memory means again the cost will increase. So that is why we have decided. Then speed and power required of the CPU and instruction set. Speed and power required means here it will come the scan time. The scan time is the execution cycle of the PLC. Always if the scan time is scan time less means then the cost will increase. That is, shorter the scan time, the cost will increase. If cost is not an option, then we can go for shorter scan cycle. If cost is the major thing, that is the cost should be less, then we have to compromise with the scan cycle. Manufacturer support and backup. So this is also most important. We should have a manufacturer support. These are some of the main considerations we need to we should see before selecting a PLC. Okay. And next we will see what is the difference between our PC and PLC. That is our computer system and PLC system. The first one, price per function. If you consider in the PLC system per function, the price is very low in the PLC. But in case of computer system, it is high. And the physical size. What is the size of the PLC and system, computer system? You see, the PLCs are very compact in size. But computer systems, they are a bit bigger than our PLCs. Operating speed. Operating speed in both of them, it is fast only. And the electrical noise. In the PLC systems, its immunity is good. And in computer system, it is much more good. Installation. In the PLC, simple to program and install. In the PLCs, we will be using the ladder diagram. It's very easy to program and also it is very easy to install the ladder diagram. Programming extremely time consuming. In the computer system, it takes more time. Capable of complicated operations. In PLC systems and in computer systems, we can it's capable of doing complicated operations. Ease of changing functions. So ease of change the functions, it's very simple in both. Maintenance. Ease of maintenance is good in PLC system and in computer system it is very poor. Understood? So in the today's session, if we summarize the today's session, we have seen the types of PLCs, classification of PLCs, and what are the selection criteria for the PLC and what is the difference between PC and PLC. In the types of PLCs, we have seen the two types. One is modular PLC and another one is compact PLC. In the modular PLC, we will be having, it will be permitting the expansion of modules. But in case of compact PLC, it is fixed. Everything is decided by the manufacturer. We can't expand the modules in the compact PLC. And next we have seen the classification of PLCs based on I/O modules and application ranges. Based on I/O modules, we will be having analog I/O system and digital I/O system. That is, whether the input and output, it should be analog or digital. Okay. Then again we are classifying based on application ranges. Application ranges, we have seen that micro PLCs, mini PLCs, small PLCs, medium PLCs, large and very large, where we will be using these kinds of PLCs. Okay. And what is the selection criteria? That is very important task to select the PLC for your application. And what is the difference between the PC and PLCs? Okay. After learning about the classification of PLC, now we will solve some multiple choice questions. The first question, solenoids, lamps, motors are connected to. These are analog output, digital output, analog input or digital input. The solenoids, lamps, motors, these are all the digital outputs. An example of discrete or digital control is, what is the example of digital control? Here, varying the volume of a music system, turning a lamp on or off, varying the brightness of a lamp, controlling the speed of a fan. See here, if you see the options here, varying the volume of a music system, it is a kind of a continuous signal. Okay. Turning lamp on or off, it is the digital control, only 0 or 1. So this is an example of the digital control. And varying the brightness of a lamp, again it is a continuous control. Controlling the speed of a fan, it is also a analog control. The solenoid is an example of an output device. True, false, none of the above. Of course, it is an output device. The PLC which permit multiple expansion through modules is dash type of PLC. Already we have seen this. Expansion through modules. It is nothing but a modular PLC. The compact PLC is also known as dash PLC. Compact PLC, it is also known as integrated PLC or fixed PLC. All the three are same. Compact PLC, fixed PLC and integrated PLC. The medium PLC contains dash I/O modules. So how many I/O modules are present in medium PLCs? For medium, somewhere it is around 34 to 1024 I/O modules will be there for medium PLCs. Okay. So in this topic, if we take descriptive questions, they will be asking like this. What are the different types of PLCs? Okay. Or explain the classification of PLCs. Okay. And what are the considerations, basic considerations for selecting a PLC for a task. These are some of the descriptive questions they may ask. Okay. Thank you.